Assalamualaikum and salam sejahtera to Dr. Ashanira binti Madris. Today, we, Group 7, will be presenting our group tasks, which are Project 1 and Project 2. The slides will be elaborated by me, Muhammad Bashir bin Zainuddin, and along with Ashwini, anak perempuan Ana Malai, as well as Suvitra, anak perempuan Tanah Raju. The following slides will cover topic 1 through topic 9, which an exception, being appendix, will exclude pictures and screenshots as we have prepared a video demonstration for both projects in result and discussion instead. To give an overview of the whole group work and presentation, I will begin the presentation with Constitutive Summary. Internet of Things or IoT plays a very significant role to contribute to the efforts of realizing IR 4.0. One of the most important components of IoT is embedded systems, which covers microcontrollers, development boards, among others. There are two projects that demonstrate the application of a development board. The solution is documented in a flowchart as well as discussing the circuits, code, results, conclusions, and outputs with image or screenshot of evidence in the appendices. Finally, the task distribution among group members are documented. IoT describes the network of physical objects embedded with sensors, software, and connectivity for varying purposes. Embedded systems are one of the most essential IoT components in which it covers the mixture of software and hardware, such as microcontrollers. Microcontrollers are used for specific tasks by many appliances, including digital cameras and washing machines. It executes processing based on inputs and generates results as an output. An instance of a microcontroller used in this project is the Esp32 board. Esp32 uses low power, consists of many peripherals, including ADCs, DACs, and SPI, and is compatible with MicroPython firmware.
One of the auditorium room at PSNZ Library has a main stage for people organizing conferences, seminars, and presentations. The lights installed to brighten the stage can be only turned on and off. Meanwhile, the air conditioner is broken, causing fluctuations in temperature of air on the stage. Therefore, on-stage presenters have complained about the inability to control the dimness of lighting and having to manually readjust the air conditioner to a right temperature repeatedly. To further elaborate on the problem, I invite Suvitra to speak.
Thank you, Bashir. Here is the problem statement for both projects. Project 1 emphasizes on how to design a circuit and writing Python code to control the dimness of an LED using a potentiometer. The provided minimum requirement components for this problem is as follows: ESP32 and micro USB cable, potentiometer, breadboard, jumper wire, resistor, and LED. Problem statement for Project 2 elaborates on how to measure air condition, temperature, and humidity using DHT11 sensor while connected to the ESP32 board, which is also connected to Wi-Fi to establish an internet connection. The provided minimum requirement component for this problem is as follows as well: ESP32 and USB micro B cable, DHT11 to verify the temperature and humidity Wi-Fi connection. Next is objective. Next slide, Bashir. Yes. Using required components stated in corresponding problem statement, Project 1 is to study, design, and develop Python coding and an appropriate circuit to control the dimness of LED, whereby the Project 2 is to study, design, and develop Python coding and an appropriate circuit to take measurement of surrounding air. Here comes the proposed solution. Next slide, please. Project 1. The circuit will help to control the dimness of LED. The circuit uses potentiometer to control the intensity of the LED. Third, the circuit will read the suitable code that will upload to Active and control the devices. For project 2, a circuit is built using ESP32, DHT11, jumper wire and micro USB cable. Favorite IoT cloud will be used to store data of temperature and humidity. Last but not least, favorite IoT cloud will be used to send email that could notify users about the increase in temperature and humidity fall. Next slide. Now let's look into the methodology of flowchart of the project 1 and project 2. Project 1. First, we have to study the component to understand the function. Then we have to build a circuit using given component. To access the circuit, we have to develop valid Python code. If the code is failed to run, then we have to make sure fix the circuit properly so that we have to build the circuit again. Therefore, if the code valid, we able to control dimness of the LED using the circuit we have built. Then project 1 is considered successfully completed. In project 2, we also need to identify the component before build the circuit, then build the circuit accordingly. Again, to access the circuit, we have to develop Python code. For this project, we also need to create a project in Favorite IoT Cloud to store data published as the circuit detects the temperature and humidity. Therefore, the temperature should be greater than 29 degrees or humidity should be lesser than 70 to notify the authorized user through email. Now, I will pass the presentation to Ashwini.
First, ESP32 is connected to laptop using micro USB cable. Then, ESP32 is burned. The following Python code is written in UPyGraph to read and control the dimness of LED. The code is downloaded and run. As we can see here, the circuit is set up as follows using components that is listed in Project 1. Project 1 is successfully built. As the dimness of LED is adjusted using potentiometer, UPyGraph able to read and show the value of dimness of LED between 0 to 1023. Okay, so just now we have watched demonstration for project 1. Now let's look at Bashir's demonstration for project 2.
When the connection is established between the ESP and UPyGraph, download the file into the ESP board. So in the terminal, it is measuring the air temperature and humidity. This data can be seen recorded in the Favor IoT platform. So the temperature is 31 degrees Celsius and humidity is 64%. Since the temperature is exceeding 29 degrees and the humidity falls under 70%, I have received the email that says you are receiving this message because one of the rules has been activated. The function that define this rule lies here, rules, and there are two rules, each for temperature and humidity settings, and that's it for project 2.
So now, I would like to conclude what we have learned from this group project. For project 1, we can conclude that a circuit is successfully built using ESP32, USB micro B cable, potentiometer, breadboard, jumper wire, resistor, and LED. We have learned on how to control the dim of LED using potentiometer with a suitable Python code in UPyGraph. And we also able to print the value of brightness of LED in UPyGraph. From project 1, we also learned that it is important to us to know on how to control the brightness of LED in daily life, especially in saving electricity. For project 2, we can conclude that we managed to develop a circuit that was able to read the temperature and humidity fall using given components. Besides, we also learned to store data in Favor IoT Cloud and managed to receive notification to our email when the temperature exceeded 29 degrees Celsius or relative humidity fell below than 70. So let's move to how we distribute the tasks for this group project. For task distribution, the report has 9 topics. So each team member was tasked with 3 topics as depicted in the colored boxes figure. As we can see here, Bashir handles in executive summary, introduction, and problem statement. Suvitra prepare objective, proposed solution, and methodology. And last but not least, I handle in doing result and conclusion, result and discussion, conclusion, and appendix. For PowerPoint preparation, YouTube presentation, and circuit preparation and coding, we all have contributed well and we all have tried our best in these 3 parts. That's all from us. Thank you, everyone.
Thank you, Doctor.
Thank you, Doctor.